All right, so today my name is Archer, and I'm going to talk about the nutrient supply in the southeast China Sea after Typhoon Morakot, which is which the author is C.C. Hong. Yes. Okay, so in the introduction. So like, so our topic is about like the place is located like, in southern East China Sea. So where is southern East China Sea? Here, and we're specifically aimed in the southern East China Sea. So like this is like the place in here, and the place that we get sample from will be mentioned later on. And why is it important? Because the East China Sea is one of the largest marginal sea in the Western Pacific Ocean, and with that, there's very important fisheries, including mackerels and sword-tip squids in there. And those high amount of fisheries or those species they need to feed on phytoplanktons. Yes. And the question is like, where do the phytoplankton get their nutrients? So there are three that is listed on the slide. The first one is the upwelling event occurring in the southern East China Sea, which is in the northeastern Taiwan. And yes, there's a clarification I must make it because the upwelling event, like the seawater is the upwelling seawater is meaning the sub subsurface current by the Kudashio currents. So it's a pretty massive, but yeah, since the place they took sample on is only on like several spots, and so I cannot give a clear like where exactly does the upwelling event take place. And all right, so let's move on to second about the nutrient of phytoplankton. And yes, the phytoplankton growth is limited in the summer compared with the winter. And yes, it is lack of nutrient, including nitrate and phosphate, or even silicate. And the third one, like without the nutrients, how do they grow? So in summer in the East Asia, there's a thing called typhoon. So or in the winter, there's things from there's an event from the continent of Asia, which is dust storm that will bring a lot of nutrients to the ocean. So these are the two factors which we call like extreme atmospheric events. All right, so another question is like, how do typhoon provide nutrients? First of all, they they have two kinds of nutrients to provide. Like first one is the oceanic nutrients, which is from the upwelling that the typhoon like it had mixed all the water around and eventually caused upwelling. And the second one is when they hit the like terrestrial, when they hit an island or they hit a continent, like they will bring the precipitation will eventually bring all those nutrients down to the ocean by river discharges. All right, so heading to our subject today, the cases we're going to take today is the typhoon Morakot. And yes, people may be wondering about what its passage, so yes, I got it here. So we can see it mainly affects Taiwan on the southern East China Ocean from August 7th to August 9th, and then it get into the mainland China, so it does not have further on, or it has a minor effect on it. All right, so we can see during the Morakot typhoon that there are a high amount of precipitation that has rained in Taiwan, and the peak is 2,070 and 80 millimeters. But people may be wondering about like how's like the annual average rainfall in Taiwan. But yes, according to my data that has has searched, it was like 2,000 and like about 2,020 millimeters. So like yes, in that 3 days, the precipitation has rained and has dumped like more than annual rain average at rainfall in Taiwan. And yes, this is the rainfall image that each place took during the typhoon. All right, so with these amount of rainfall, like, and the low strong wind, they must cause devastating floods and demolishing destruction through the Taiwan. And there are some images that is shown here. Yes. All right, so for this research, the purpose of this research is to find out the difference in nutrient supply before and after the passage of Morakot typhoon. Okay, moving on to the materials and method. Like, when we need, the main issue that we got here is to collect water sample, and yes, we need those two ships to help us collect those, and which is the Ocean Researcher 2 and the fishing boat Koyami. And on the material, the equipment on the Ocean Researchers includes like conductivity, temperature depth recorder, which is called CDD, and transmissometer, which, like, it's pretty simple. It's like it shoots a beam and the other side of it collects the beam, and like, yes, mainly is try to know the turbidity, or like how much sediments is between the water. And yes, moving on, there's our CD rosette and the Neskin bottle, which is the bottle to collect water samples. Those are going to be a set, and after we collect those, we need to filter it, and we got the filter here. All right, so how do we collect all those water samples? We collect them in, like, we want to find out the nutrient concentration at depth, like for water surface, or to 10 meters, 25 meters, up to 100 meters. And the items that we want to know is the nitrate, phosphate, and chlorophyll A. So yes, we collected, and the places we collected from is here, which I have said before that I'm going to show you, like where do we collect that. And please notice that the winds, we can see it's going like it's going like counterclockwise. And so you can see, like, overall, afterwards we can see the river discharge happening, and yes, the direction is from here. All right, so moving on to the result and data, we have to see, like, before the typhoon occurs, which at time the collect sample is like in July 22. And yes, we can see, like, yes, we got this get here. Yes, this sentence in here, like, the surface water of the temperature is about 28 degrees Celsius, and the salinity range from 33.6 to 34.5. You can see here clearly. And same as the nutrients, which is nitrate and phosphate, it's pretty low under normal condition. And same as chlorophyll A. Yes. Okay, so after a typhoon came, we can see here, there's an upwelling occur. Like, to rephrase it again, the typhoon occurred in August 7th to August 9th, mainly that affects the southern East China Sea. So afterwards, like 2 days after the typhoon came, which is August 11th, upwelling occurred. So we can see, like, there's a significantly low temperature happen to be in the water surface in here, and we can see the salinity here has a little bit changed. Yes, just a little bit in here. And as for nitrate and phosphate, we can see in August 11th, it also increases. It also increases a bit in here. Sorry, I have to go back here. And another thing we need to see about is, like, in August 18. In August 18, like, there's a chunk of, like, the temperature has gone a little bit lower, and that will be what I said about the river discharge in here. And we can see, yes, the salinity has dropped significantly. And yes, and we see here, in nitrate and phosphate, and we can see after a river discharge, we can see the concentration of the phosphate is not like the percentage of the phosphate is a little bit higher than nitrate. So during this, we can conclude that phosphate is not a limited factor of phytoplankton growth in the southern East China Sea in here. And yes, we have another comparison in here. Yes, after the upwelling, like after a few days after the phytoplankton, the chlorophyll has the number of chlorophyll has increased, and which is caused by the phytoplankton growth or algae bloom in here. And yes, it does not occur immediately due to some reasons. One is because yes, a typhoon has just passed, so the water has mixed pretty well, and so the phytoplankton, some of the phytoplankton has moved like to the deeper ocean and cannot get enough sunlight, so they need to move. You need to wait afterwards to let the algae bloom. And yes, we can from the data we can see like that nitrate and phosphate during the typhoon period has provide like 86 and 87% of the of nitrate and phosphate in the summer, in that summer in 2009. Yes. And so moving on to the conclusion, we can conclude that nutrient supply through episodic typhoon events provides an important contribution to phytoplankton growth. And as I mentioned, accounting like 86 of nitrate and 87 of phosphate supplies were induced by Typhoon Morakot. And yes, that's simply what I have today. Thank you for your attention.
I think your words are combined with the data and the map is great. It's greater than the before, and it has a mark showing us where the typhoon came and the upwelling, and also you have words to help us to understand the graph. I think that's great.
Thanks.
Yeah, you show the location right after you mention it this time. I think it's good. And I think if you can add some picture of the tools they use, it would be easier to understand. Thank you.